So, hello, dear students. Good afternoon to one and all. Um, I hope I am visible and audible to all of you. Am I? Just let me know in the chat box if I am visible and audible to all. Yes? Okay. Okay, let's start with the class today. So, today we are seeing the crash course part of both 11th and 12th. Okay. So, in today's session, we are going to deal with the thermodynamics chapter. And in that, we will see the first half of thermodynamics today, and then we will continue the the second part of thermodynamics in the next session. Okay. So for today's session, I will give some gist of the theory part of thermodynamics, the first half of thermodynamics, and then I will discuss the questions, previous year's questions of JEE and NEET on this topic. Okay. So moving on to the session, yeah, the topics that we are going to cover today is mainly the first law of thermodynamics, and in that we will discuss some of the basic terminologies in thermodynamics and internal energy part and law of conservation of energy, types of work, expression for work, enthalpy and internal energy, and heat capacity. Okay, so these are the things we are going to discuss today. Now, moving on to the first topic, which is basics in terminology, which is the basics in terminology. Just give me a second. Yeah. So there are three terms uh, which are being used in thermodynamics. One is the system, and second is the surrounding, and third is the boundary. So what is a system? System is the part of the universe under study. Okay. So here you can see this is a container which has a piston attached to it, and inside that container we have some compounds, right? So that is called a system. That is the part of the universe under study, and all the observations are made on the system. Coming to the surrounding, yeah, good afternoon JNV Bhavnagar students, good afternoon. So coming to the surrounding, the remaining part of the universe is called as surrounding. Okay, it can or it cannot interact with the system. Now coming to the boundary, the separation between the system and the surrounding is called as boundary. Okay, so this is about the system, surrounding and boundary, which are very easy to understand. Now let's go with the next part, which is the types of process. So here in this lesson we use 5 types of processes. First one is isothermal. So what is iso? Iso means same, thermal means temperature. So here the temperature is going to be same. Okay, so if the temperature is same, if the temperature is constant, then the delta T value will be equal to 0. Okay. And for isochoric, volume will be constant. So delta V will be equal to 0. And for isobaric process, delta P is equal to 0. And for here pressure is constant, so that's why delta P is equal to 0. And for cyclic process, for the cyclic system, both initial and final state will be same, right? So in that case, you see here, for a cyclic system, the initial point is 1 and the final point is also 1. So everything remains constant there. And coming to the adiabatic process, there will be no heat exchange or transfer between the system and the surrounding takes place there, okay? So that is adiabatic. So there is no heat exchange between the system and the surrounding. Those processes are called as adiabatic process, and the wall, the boundary is called as adiabatic wall. So these are the 5 very important types of process we learn in this lesson. Okay. Then the next is types of properties. So we have two types of properties. One is intensive and the other one is extensive. So what are intensive properties? So the properties which do not depend on quantity of matter, they are called as intensive property. Okay, they will not depend on the quantity of, they will not depend on the mass of the substance. Examples are temperature and pressure. I'll show you an example. So here I have taken an ice cube. Okay, and the temperature of the ice cube is 0 degrees Celsius. Now if I divide this ice cube into two, or if I take one more ice cube like this, okay, so now I have two ice cubes. The temperature of both the ice cubes are same 0 degrees Celsius. Okay, both the ice cubes are having the same temperature. Okay, so here even if I change the mass, if I increase the mass or if I decrease the mass, the property is going to, the temperature is going to remain same. So that's why temperature and the other properties are called as intensive property. Now coming to the extensive property, the properties which depend on the quantity of matter are called as extensive. They depend on the mass, example volume, mass, etc. Now you see, so first initially I have 5 kilogram of wooden log, 5 kg wooden log I'm having. Now if I add these two, I will get 10 kg, right? Now the property is changing, the property, the mass is changing and the volume will change, everything will change, right? Those properties are called as extensive properties. Okay, so examples are very important. Now coming to the types of function, there are two types of function. One is state function and the other one is path function. Now coming to the state function, they are the function which depends only on the initial and final state. Okay, examples are internal energy, enthalpy, volume, pressure, temperature, etc. So all these properties, if you see, they depend only on the initial and final state. They don't depend on the path in which the reaction or the process occurs. Okay, so those functions are called as state functions. Now coming to the path function, it is the opposite of state function. They depend on the path of the process. Okay, for a single process, we can have many paths, right? So in the picture, you can see 1 to 2 is path A and 1 to 2 is, and here path B. And if I want to go from 1 to 2, I can use both the paths. Okay, so they depend on the path. They do not depend only on the initial and final state. They depend on the path in which the process occurs. So the examples are work and heat. Examples are work and heat. Only two examples are there for path function. Remaining all others are state functions only. Okay, very important. You have to study the examples of the path function which are work and heat. Work is denoted by the letter W and heat is denoted by the letter Q. Okay. Now I'll go with the next topic, which is first law of thermodynamics. So this is the main topic, and under this some subtopics are there. The first subtopic is internal energy. So internal energy is denoted by the letter U. Okay. So the properties of internal energies are, first of all, it is represented by the letter U. Okay, and it is a state function, means it depends only on the initial and final state of the system, and the dependent only on the change in temperature of the system. Yeah, if the temperature increases, internal energy also increases. And also it is an extensive property whose value changes on changing the quantity like mass, etc. And the SI unit of internal energy is joule, and the total internal energy cannot be measured, only the change in internal energy is measured. So U cannot be measured, only the delta U can be measured using the calorimeters. Okay. Now coming to the next subtopic, which is the law of conservation of energy. Basically, the internal energy can be changed by three ways. Okay, one is heat exchange between the system and surrounding, and the other way is it can be changed by the work done on the system or by the system. Third is when the matter enters or leaves the system, internal energy changes. Okay, first let's go with the heat. So first of all, what is heat? What is heat transfer? And how does a heat transfer? Always heat transfer from a warmer object to cooler object, right? So the temperature will go from hot to cold object. And when the heat enters into the system, here you can see in the picture, when the heat enters into the system, then we have to represent the Q as in positive term. And when heat comes out of the system, then the Q value will be negative. Just keep in mind, okay? When the heat enters into the system, if we are giving the heat to the system, then the Q value should be positive. And when the heat is coming out of the system, then the Q value will be negative. Okay? Now coming to the work. Coming to the work. Mechanical work. So energy exchange between system and surrounding against a constant external pressure leading to volume change of the system is called as work. There are two types. One is expansion occurs and the other case compression occurs. If the so there is a system, piston is attached to the system and we have some gas molecules over here. Okay, and the gas molecule will exert some pressure that I'll denote as pressure of the internal gas. Okay, and I can apply some pressure, right? That is the external pressure. That is the external pressure. So the gas is having some pressure, that is internal pressure, and if I give some pressure externally, that I'm calling as external pressure. If the internal pressure is greater than the external pressure, gas will do some work and because of that expansion occurs, right? So gas will do some work because of that expansion of the gas occurs. And the pressure which I am giving, that is if external pressure is greater than the internal pressure, what happens? So this pressure is more. So what happens because of that? Compression occurs. So volume will get decreased. Okay, compression occurs in that case. Now, coming to the sign convention of this work, if the work is done on the system, if the work is done on the system, then the value should be positive. Value should be positive. And if the work is done by the system, if the system is doing some work, expansion occurs, right? Here you see system is doing some work here. Because of that expansion of the gas occurs. In that case, W value will be negative. W value will be in that case, it is negative. Got it? Yeah. Then coming to the next topic, which is types of work. There are two types of work. One is reversible work and the other one is irreversible work. Okay, so two PV graph for both the types of works are shown to you. And in case of reversible and irreversible, we have some area under this pressure volume curve. If I want to find out the maximum work done, then I have to calculate the area under this pressure volume curve. So area under the PV curve will give me the work done of that process. If the area is more, then the work done is also more. If the area under PV curve is very less, then the work done is also less. Okay. So very important relation. So the work done for any process will be equal to the area under the pressure volume curve. Okay, very important relation. Now coming to the expression of work, we have three processes: reversible, irreversible, and free expansion. Okay, for isothermal expansion of an ideal gas, we have to use these three formulas to find out the work done. For reversible, it is minus nRT into ln, logarithmic function of V2 by V1. And for irreversible, minus P external pressure into delta V. And for free expansion, work done will be 0. So these three formulas is you have to note it and study, very important. Now coming to the next topic, which is enthalpy and internal energy. So the properties of enthalpy, it is denoted by the letter H and it is a state function. SI unit is joule Again, like internal energy, enthalpy cannot be measured, but change in enthalpy can be measured using the calorimeter. And the formula that is being used is del H is equal to U plus PV. Okay, H is equal to U plus PV. Coming to the sign convention of this enthalpy, if the process is exothermic, delta H will be negative, and if the process is endothermic, then delta H will be positive. Exothermic means heat energy will be released. Energy will be released from the system. And if the energy is getting absorbed by the system, then we call that process as endothermic. Okay, in that case, delta H value will be positive. Okay. Then the next is the relationship between delta H and delta U. This is one of the very important formula. You have to note it. Okay. Delta H is equal to delta U plus delta NG RT. Delta NG RT. Okay. Then the next topic is heat capacity. So what is heat capacity? It is the heat required to raise the temperature of the system by 1 degree Celsius. SI unit is joule per Kelvin. It is an extensive property. Formula is Q is equal to C into delta T. More heat capacity means more heat is required to raise the temperature. Got it? And we have two types of heat capacity. One is molar heat capacity and the other one is specific heat capacity. Okay? If the heat is required to raise the temperature of 1 mole of a system by 1 degree Celsius, it is molar heat capacity. Okay? When the heat required to raise the temperature by 1 kilogram of the substance by 1 degree Celsius means it is called as specific heat capacity. Okay. Now here molar heat capacity as well as specific heat capacity, both are intensive property. And here this is for 1 mole of the system, right? So the SI unit is joule per Kelvin per mole and here it is joule per Kelvin per kilogram. And the formula that you have to use is Q is equal to N into Cm delta T. And here Q is equal to M into Cs delta T. Got it? So both N and M represents the number of moles. So just the letter changes for both. Okay. Now, the relationship between Cp and Cv. So the relationship is Cp minus Cv is equal to R for 1 mole of an ideal gas. Okay. For 1 mole of an ideal gas, the relationship is Cp minus Cv equal to R. Got it? And also we have one more relation which relates this Cv and delta U and Cp and delta H. Okay. So Qv is equal to Ncv delta T which is equal to delta U and Qp is N into Cp delta T which is equal to delta H. So these are the very important formulas you have to keep in mind while studying first law of thermodynamics. Okay. Now we will solve some previous year's questions of JEE and NEET related to the topics that we have discussed. Okay. So let's start with the first question. Which among the following options is the correct relation between change in enthalpy and change in internal energy? So just now we have seen, right? So what could be the answer? What is the correct answer? What is the correct answer for this? So which among the following options is the correct relation between change in enthalpy and change in internal energy? Yeah, very good. It is option A, right? So delta H is equal to delta U plus delta NG RT. Option A is the correct answer. So straightforward questions from the formulas are being asked in this lesson. So try to concentrate more on this. Try to study the formulas clearly and properly and get good marks. Got it? Now we will move on to the next question. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from 1 liter to 10 liter volume. Delta U for this process is. So what we have to find out? We have to find out delta U. Okay. Now, here the system is given as expanded isothermally. For isothermal expansion, isothermal means delta T will be equal to 0, right? So these are the things, and volumes are given, temperature is given. We know that delta U is equal to NCV delta T. Just now we have seen this relation, right? Delta U is equal to NCV delta T. Now here delta T goes to 0. So delta U will also be equal to 0. Delta U will also be equal to 0. So the answer is 0 joule. Option A. Option A is the correct answer. Okay. Yes. Now coming to the next question. Coming to the next question. Which of the following PV curve represents maximum work done? Which of the following curve represents the maximum work done? So I have already told you to find out the maximum work done, go for the area under the pressure volume curve. Okay, if the pressure area under pressure volume curve is more, then the work done is more in that case. So observe all the options. So here in the first case, this is the work done, and in option B, this is the area under PV curve, and here we don't have any area, it is a straight line, and here this is the area under the PV curve. So it is clear that from option B, work done is more because the area is more in option B. So option B represents the maximum work done. Okay, fine. Coming to the next question. Which one among the following is the correct option for right relationship between Cp and Cv for 1 mole of ideal gas? Again, just now we have discussed. It is Cp minus Cv equal to R. Option C. Cp minus Cv equal to R. Right? Very easy. Coming to the next question. The correct option for free expansion of an ideal gas under adiabatic condition is. So here in the question says that it is free expansion. If it is free expansion, then the external pressure will be equal to 0. Then only it will expand so freely. If the external pressure is equal to 0, we know that W is equal to P external into delta V, right? So if P external goes to 0, then work done will also be equal to 0. And also the question says that the system is adiabatic. For adiabatic process, for adiabatic process, Q will be equal to 0. Okay. And from first law of thermodynamics, we know that delta U is equal to Q plus W, right? So Q also goes to 0 and W also goes to 0. So delta U will be equal to 0. Delta U will be equal to 0. So from the given option A and option D says that Q is equal to 0 and option D says that W is equal to 0. So obviously option D will be the correct answer. And how delta T is equal to 0? Because you can use this relation. Delta U is equal to NCV delta T you can use. Okay. And here from this relation we know that delta U is equal to 0. If it is equal to 0, then the whole term will be equal to 0. Means only when delta T goes to 0, it will be equal to 0. Okay. So the whole term will remain. Delta T is also equal to 0. So option D is the correct answer. Okay. Coming to the next question. Under isothermal condition, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure of 2 bar. The work done by the gases. Now, so what are the given values? Let me write the given values. So here the external pressure, constant external pressure is given as 2 bar. Okay. And volume they are given. So V1 is equal to 0.1 liter and V2 is equal to 0.25 liter. So these are the given values. We have to find out the work done. So how to find out the work done? So work done is equal to minus P external V2 minus V1. Okay, we have constant external pressure, so it is irreversible process. So we have to use this relation. Now substitute, external pressure is 2 bar and V2 is 0.25 minus 0.1 liter. So the answer will be minus 2 into 0.15 bar liter, and here it is equal to minus 0.30 bar liter. Okay, so here we have to represent the answer in terms of joules, because in all the options it is given in terms of joules. So we know that 1 bar liter is equal to approximately equal to 100 joule. 1 bar liter is approximately equal to 100 joule. So I can multiply this number by 100. Okay, if I multiply this by 100, I will get the answer in terms of joules. So it will be equal to minus 30 joule. So the work done for the given process is minus 30 joule. Which option? C is the correct answer. Okay, just only one formula we are going to apply. Rest all are so easy. So moving on to the next question. A gas is allowed to expand in a well-insulated container against a constant external pressure of 2.5 atmospheric pressure from an initial volume of 2.5 liter to a final volume of 4.5 liter. The change in internal energy delta U of the gas in joules will be. So we have to find out delta U. And we know that delta U is equal to Q plus W. Okay. And the question says that the container is a well insulated container. Insulated means there is no heat exchange between the system and the surrounding. So in that case, Q will be equal to 0. So this equation becomes then delta U is equal to W. So if we find out the work done, that was going to be equal to this delta U. Right. So what is the work done? How to find out the work done? Now again the constant external pressure is given as 2.5. So let me write the given values. Constant external pressure is 2.5 atmospheric pressure, and volume, initial volume is 2.50 liter and the final volume is 4.50 liter. Okay, now we have to find out the work done. It is going to be equal to minus P external V2 minus V1. So it is equal to minus 2.5. So into 4.5 minus 2.5. Okay. So it is going to be equal to minus 5 liter atmosphere. Now to convert this liter atmosphere to joule, what I have to do? I have to multiply this by the number 101.325 joule. Okay. So it is going to be equal to minus 506.625 joule. So this is the answer. So in which it is again equal to delta U, change in internal energy. Now the approximate value which is nearest to this 506 is option B, minus 505 joule. Okay, that is the answer. Now coming to the next question. The total number of intensive properties from the following is. The total number of intensive properties from the following is. So what are intensive properties? The properties which do not change on changing the size of the system. Right. So here intensive properties are the properties who are independent of the amount of the substance. Independent of the amount of the substance. Those properties are called as intensive property. And here if you see, the molarity will fall under this intensive property, and the E naught cell, and molar mass, and molar heat capacity. So all these four properties are coming under intensive, whereas volume gives free energy change delta G, and the mole. Okay, They are the properties which changes, whose value changes on changing the size of the system. So they are extensive property. Now here the molar heat capacity, molarity, E naught cell and molar mass. These four are intensive property. So the total number of intensive property from the following is 4. Okay, they are 4. Fine. Coming to the next question. When a 60-watt electric heater is immersed in a gas for 100 seconds in a constant volume container with adiabatic walls, the temperature of the gas rises by 5 degrees Celsius. The heat capacity of the given gas is dash joule Kelvin. How to find out? So what is given? Heat capacity we have to find out. So to find out the heat capacity, the relation is Q by delta T. Okay. Because Q is equal to C delta T, right? From that T is equal to Q by delta T. So I need Q and delta T value. So but here in the question 60 watt. So power is given. So power is equal to 60 watt. Power is equal to 60 watt and time is given. So the time is equal to 100 seconds. So from this we can find out the Q value. So Q value will be equal to power into time, right? So it is 60 into 100. So it will be equal to 600 joule. Q is equal to 600 joule. Now substitute this Q value in this relation. C is equal to Q by delta T. It will be 6000 and the change in temperature is 5. It rises by 5 degrees Celsius. So it will be 5. So when we solve this 1 and 2, 0, 0. So the C value is equal to 1200 joule. Okay. 1200. It is not joule, right? It is joule per Kelvin. Joule per Kelvin. So the answer is 1200. Okay. So I hope this question is clear to all of you. We can move on to one more question. Yeah. 1 mole of ideal gases allowed to expand reversibly and adiabatically from a temperature of 27 degrees Celsius. And the work done is also given as 3 kilojoule per mole. The final temperature of the gases. What are all the things that is being given here? The given values are 1 mole. So the number of mole is equal to 1. Number of mole is equal to 1. And it is allowed to expand. So expansion occurs. Means the work is done by the gas. The work is done by the gas. So the W value will be equal to minus 3 kilojoule per mole. Okay. And what else is given? Temperature is given. 27 from a temperature of 27 degrees Celsius. So the initial temperature is 27 degrees Celsius. And if I want to convert this into Kelvin, just add 273. You will get 300 Kelvin. Okay. Now use a relation. W is equal to NCV delta T. So N value is 1. CV is already given in the question. It is 20 and delta T is T2 minus T1. So it is equal to 1 into 20. Temperature, final temperature we have to find out. And initial temperature is 300. And the work done is given as minus 3 kilojoule. So it is kilojoule, right? To convert that into joule, multiply by minus 3 into 10 power 3 joule per mole. Okay. So I can substitute minus 3000 here. And if I want to find out the value of T2, it will come around 150 Kelvin. T2 will be equal to 150 Kelvin. Okay. So the final temperature of the gas is 150 Kelvin. Final temperature is 150. Okay. 150 is the answer. Now coming to the next question. When 2 liter of ideal gas expands isothermally into vacuum to a total volume of yeah, to a total volume of 6 liter, the change in internal energy is dash. So all these are JEE questions. That's why you cannot find the options over here. Yeah. So how to solve this? We have to find out the change in internal energy. We have to find out the change in internal energy. Delta U we have to find out. And volume is given as 2 liter of an ideal gas expands isothermally. Isothermal means again delta T is going to be 0 because the temperature is constant. Okay. We know that delta U is equal to NCV delta T. Delta T goes to 0. So the change in internal energy delta U is also equal to 0. So it is 0 joule. Okay. Very easy. Coming to the next question. Among the following, the number of state variable. So who are the state variable? Who are the path variable? Only two examples are there for path function. One is heat and the other one is work. So these two are path functions, heat and work. The other things are state variables, state functions only. These are the path variables or path function. The remaining are state variables or state function. So internal energy is a state function, volume is a state function, and enthalpy is a state function, but heat is a path function. So the total number of state functions or state variables is 3. Okay, answer is 3. Good, let's move on to one more thing. The molar heat capacity for an ideal gas at constant pressure is 20.785 joule per Kelvin per mole. Molar heat capacity, that is given. The change in internal energy is also given as 5000 joule. Upon heating it from 300 Kelvin to 500 Kelvin, temperature is also given. The number of moles of the gas at constant volume is, we have to find out the number of moles of the gas. So how to find out? Molar heat capacity at constant pressure. So it is, the given values are Cp. Molar heat capacity is C and at constant pressure it is Cp. So it is equal to 20.785 joule per Kelvin per mole. Joule per Kelvin per mole. And temperatures are given. Temperatures are also given. So the initial temperature T1 is 300 Kelvin and T2 is 500 Kelvin. Okay. And the change in internal energy is also given. Delta U is also given as 5000 joule. Okay. So we know that, what we know, delta U is equal to NCV delta T. Okay. So from this, what is NCV? It is equal to delta U by delta T. So delta U is 5000 joule and delta T, the change in temperature. Change in temperature means it is T2 minus T1, right? So 500 minus 300 is 200 Kelvin. 200, this is joule and this is Kelvin. And if we solve this, we will get as 25 joule per Kelvin. So NCV is equal to 25. So what is CV from here? It is 25 divided by N. CV is 25 divided by N. Okay. But we are asked to find out the value of N. So we can use CP minus CV is equal to R relation. We know this, right? So we know that Cp minus Cv is equal to R. Cp is given in the question. It is 20.785 joule per Kelvin per mole. And Cv we have found out 25 by N. It is equal to R. It is equal to R. And if I solve this, I will get N value as 20.785 minus 25 by N. Here we can use the R value as 8.314. It is given in the question, right? 8.314. And if we solve this, we will get the value of N as N will be equal to 25 by 20.785 minus 8.314. I will get. Finally, N value will come out to be 2. So the number of moles of the gas at constant volume is equal to 2 for this question. Okay. So first we are using delta U relation and we are getting CV from there, and using that CV we are getting the value of N, number of moles. Got it? It's very easy only, just we have to apply two formulas to find out the answer. That's it. Now coming to one more question, the last question for today's session. For the reaction H2F2 giving H2 plus F2, delta U is equal to minus 59.6 kilojoule per mole at 27 degrees Celsius. The enthalpy change for the above reaction is minus dash kilojoule per mole. And R value is given as 8.314 joule per Kelvin per mole. Okay. So we have to find out the enthalpy change. So what is enthalpy change? It is delta H. We have to find out delta H. So what else is, what are the things given here? Delta U is given. Okay. Temperature is given. We have to find out delta R is given and delta H we have to find out. So we know that delta H is equal to delta U plus delta Ng RT. Right? This formula we know. And delta U is given as minus 59.6 kilojoule per mole. Plus delta Ng. What is delta Ng? It is the change difference in the number of moles of the gaseous product minus number of moles of the gaseous reactant. So the number of moles of product is 1 plus 1. So the number of moles of the product is 2. And the reactant is also in gaseous form, but the number of mole, only 1 mole is there. So 2 minus 1 is coming out to be 1. So delta Ng value is equal to 1. And the value of R is 8.314 into the temperature. But here you see R is given in terms of joule per Kelvin per mole. But here delta U is written in terms of kilojoule per mole. So what we can do, we can divide this whole thing by 1000. Okay. And the temperature is 27 degrees Celsius. So temperature is 27 degrees Celsius. If I want to convert this into Kelvin, add 273. This will give 300 Kelvin. Okay. So put 300 in place of the temperature. Okay. Now if we solve this, we will get minus 57.10 kilojoule per mole as the final answer. Okay, so the delta H will be equal to this. Okay, minus 57.10 kilojoule per mole. Okay, so here we are using the straightforward relation and then doing mathematical steps. and then we are getting the product, final answer. Okay. So I hope this session is very useful and it is very clear to all of you. If you are having any doubts, you can let me know in the chat box. I'll give you some seconds. The next part, the thermochemistry part, we will discuss in the next session. Okay, we will discuss in the next session. Students, those who are watching from YouTube, you can also let me know if you're having any doubt. Yes. Yeah, this is sufficient for NEET. Okay, this is sufficient for this is for both NEET and JEE. And the questions are also from both JEE and NEET only. Okay, so everything is sufficient for you for both NEET and JEE. You don't have to worry about anything. Okay, so no doubt. Okay then. Okay, students, thank you so much for listening to today's session. So I'll meet you all in the next session. So till then, take care. Bye bye. Thank